Hello students, welcome back to the channel Tutor Elite Class 10th Chapter 2 Acids, Bases and Salts. So in this chapter we will come across acid, bases and salt. Okay. What are acids and what are base? What are acid and what are base? Acids are substances that release hydrogen ions. Yes, H plus. Acids are the substance that releases only the hydrogen ion, whereas bases are the substance that release hydroxide ions, that is hydrogen and oxygen. Hydroxide ions. Okay, hydroxide ions, that is OH minus. So acid releases only hydrogen ion, whereas base releases hydroxide ions, that is oxygen and hydrogen. Okay. Acids, when dissolved in water, these ions give acids their characteristic properties and reactivity. Whereas bases, these ions give base their unique characteristics when dissolved in water. So some basic examples for acid are HCl, nitric acid, sulfuric acid. HCl is hydrogen chloride, hydrogen and nitrate, that is HNO3, nitric acid, and H2SO4, hydrogen and sulfate, that is sulfuric acid. Okay. Whereas for bases, sodium hydroxide, that is sodium and again hydroxide, calcium hydroxide, potassium. K stands for potassium hydroxide. Okay. So we know that acids release hydrogen ions, whereas base release two ions, that is hydroxide, that is oxygen and hydrogen, that is hydroxide ions. Okay. And some examples for acid are HCl, nitric acid and sulfuric acid, and for base are sodium hydroxide, calcium hydroxide and potassium hydroxide. Hydroxide ions, see wherever hydroxide comes, it is simple to understand that it is a base. Okay. Next, what are the properties of acids and bases? So acid sour taste like lemon juice, sour or sour. Turn blue litmus paper red. I hope everyone knows what is litmus paper. Yes, where you can see acid, neutral and the base. Okay. Further we'll come across the litmus paper. Conduct electricity in the solution. Acids conduct electricity in the solution. React with metals and carbonates. So acids react with metals and carbonates. Okay. So what are the properties of bases? Base, bitter taste, kadwa, and slippery feel. Turn red litmus paper blue. Conduct electricity in solution. React with oils and fats. Whereas acid react with metals and carbonates, and base reacts with oils and fats. Simple properties of acid and bases are there. Acid is sour taste, khatta, whereas base is bitter taste, kadwa. Okay. Litmus paper turns from blue to red, whereas reverse from red to blue. Okay. Both conduct electricity solution. Next. Acids react with metals and carbonates, whereas base reacts with oils and fats. Okay. Next. So strong versus weak acids and bases. Okay. What is acid? We know that, which release hydrogen ions, whereas base release hydrogen peroxide, that is oxygen and hydrogen. So the strength of acid and bases depends on how complete they ionize in water. Okay. So this determines the reactivity and pH level. What is pH? pH, that is potential of hydrogen. Okay. pH is potential of potential of hydrogen. Strong acids release many hydrogen ions when dissolved, that is HCl, that is hydrochloric acid, sulfuric acid, nitric acid. Okay. Whereas weak acid release fewer, that is less hydrogen ions when dissolved in acetic acid, citric acid and carbonic acid. Okay. they release many hydrogen ions, and they release strong acid release many hydrogen ions compared to the weak acid. Weak acid release fewer, that is less, you can say. Next comes the strong base. Strong base release many hydrogen peroxide ions. OH, right? We know that base releases hydrogen peroxide when dissolved in sodium hydroxide. That these are strong bases, right? Sodium hydroxide, potassium hydroxide, and calcium hydroxide. Whereas weak, again less hydrogen peroxide ions when dissolved, like ammonium hydroxide, sodium bicarbonate, calcium carbonate. Okay. So this is the difference between the strong acid and strong base, and weak acid and the weak base. Strong acid releases many hydrogen ions compared to weak acids, and strong base releases more hydrogen peroxide ions compared to weak base. Okay, next. So how do we indicate whether it's an acid or base? Chemical indicators are substances that change color depending on whether they are in acidic or basic solution. These color changes help us identify and measure the pH of substance. Like red in acid, blue in base, the most common and simple indicator. See, from 1 to 7, it is acidic in litmus paper. Okay, from 1 to 7 it is acidic, that is red. If you dip in a solution, if you get a red color, then it is a acidic. Okay, 1 to 7. Whereas 7 is neutral. And after 7, the base starts. That means if you dip a litmus paper in any solution, and the litmus paper turns blue, yes, it turns blue, then it's a base. Okay, first we shall take the example of methyl orange. Red in acid, yellow in base, used for titrations. Okay, so methyl orange, red in acid means it's a acidic, right? Because the acid is from 1 to 7, it is acidic, and from 7 is again neutral. Matlab 1 to 6 is acidic till 7. 7 is a neutral, and after 7 the base starts. Greater than 7 it's a base. Okay. So methyl orange ranges from 3.1 to 4.4. So it's a acidic. Okay. And yellow in base. Basically used for titration it is. Okay. Next. Phenolphthalein. Okay. Colorless in acid. Phenolphthalein colorless in acid, basically. Pink in base, great for neutralization reaction. Okay. So phenolphthalein, that is its pH range is from 8.2 to 10.0. That means it's again a base, but the color is pink. Correct. This is methyl orange is acid, red in acid, right? Yellow in base. But phenolphthalein, the color is colorless in acid, that is no color. Pink in base, that means it's a base because its pH is from 8.2 to 10.0 ranges. Okay, next. So, chemical reactions of acid and base. Acid and base participate in characteristic reactions that produce useful products and demonstrate their chemical properties. Acid and metal. This is your acid, 2HCl, and zinc is a metal. So it forms zinc chloride and hydrogen gas is released. Okay, the arrow indicates the release. Next, bubbles of hydrogen gas are visible during this reaction. Next comes the acid and metal carbonate. See, metal is a calcium is a metal again. Carbonate, CO3 is a carbonate. Yes, carbonate. So it gives rise to calcium chloride, carbon dioxide is released, and water is formed, मतलब water droplets. Okay. Carbon dioxide gas produces effervescence. Next comes the acid plus base neutralization. See, acid, HCl, correct, base, sodium hydroxide, gives rise to sodium chloride and water. This reaction is exothermic. Exothermic means exothermic means reaction that produces heat. Yes, it is given and releases heat. Reaction that produces heat or releases heat, that releases heat. Yes, very simple. Chemical reactions of acid and bases. Okay, next. pH scale measuring acidity and basicity. See, as I said you, the pH scale is a logarithmic scale that measures the concentration of hydrogen ions in solution ranging from 0 to 14. Hydrogen ions, it's not visible here. I'll just change the color. Okay, hydrogen ions, H plus ions. Yes, we know that H plus ion stand means acid releases. Yes, acid releases hydrogen ions. OH ions, that is base releases, OH ion. Now, how will come to know how much is acid and how much is base? Acidic is from 0 to 6. That is high H plus ion concentration, like lemon juice, pH is 2, vinegar 3, tomatoes 4. pH. What is pH? Potential of hydrogen. Potential of hydrogen. Yes. So the acidic is from 0 to 6, where 7 is a neutral, that is equal hydrogen and hydroxide ions like water, pure water. Next, the base starts from 8 to 14, that is high hydroxide concentration ions like baking soda, soap, bleach. Yes, see, one thing we can see that baking soda, soap, bleach, we can easily use it. Yes, the quantity we want, but till a certain level. Lemon juice, we cannot use it more. Vinegar, no. Yes. Okay, so this is a pH scale basically used for the indication. Is basically a pH scale, litmus paper. Litmus. This is not a litmus paper, huh? But by this scale, we'll come to know that from where it is, where to where it is acid, and from where to where it is base, and which is a neutral. From pH 0 to 6 is the acid, 7 is a neutral, and 8 to 14 is your base. Okay, so this is your pH scale. Everyday importance of acid, base, and salt. These chemical compounds play a crucial role in our daily life, from biological process to household application. That is, biological means inside us to outside us, and environmental concerns, surroundings. First comes the biological process, that is digestion. Stomach acid, HCl, breaks down food and kills harmful bacteria, maintaining a pH of 1.5 to 3.5. So what is a pH? That is potential of hydrogen, that is 1.5 to 3.5. Acidic, that is concentrated acid. Okay. For optimal digestion, that is just to kill the harmful bacteria, the acidic is 1.5 to 3.5 pH range. Next comes cooking and cleaning. Baking soda, baking soda, that is sodium bicarbonate, a mild base. Okay, helps dough rise and remove tough stains. Example for baking soda, example I can give. We add for the food, for the fermentation, and remove tough stains even. Okay. Vinegar, acetic acid. Vinegar is also known as acetic acid, which is used in the food like Chinese and etc. Chinese and etc. Okay, is used for preservation. So acetic acid is used for the preservative. Okay. Next comes the essential nutrients. Table salt, that is sodium chloride, the salt which we use regularly. Yes, regulates fluid balance and nerve function. We need salts for survival and proper body function. See, if the salt is if the salt is less, yes, it's called hypothyroidism. Hypothyroidism, yes. If the salt level is high, it's called hyper. Hyper. If the spelling mistakes, please correct me in the comment section. Okay, hyperthyroidism. That is simple goiter. Yes, thyroid. That is lack of iodine, basically iodine, and table salt, again iodine. Environmental impact. Acid rain, pH from 5.6. See, 5.6 is the acid. Again, 6 is neutral. 7 is neutral. And from 7 to 6 is neutral. Sorry. I'll repeat this point once again. Okay. So, environmental impact, acid rain, that is ranges pH is 5.6, correct, which is acidic, and 6 is neutral, and from 7 to 14 it is base, correct, base. Forms when pollutants react with water, damaging ecosystem, buildings and aquatic life. Buildings, I can give one example for you people as Taj Mahal. Taj Mahal is basically made up of marble, right? But slowly, the color is changing of the Taj Mahal. Last news what I came through. So that is because of acid rain. Okay. That's it for today's class. Everyday importance of acid, base and salts in our daily life, inside as well as outside. Thank you for watching the video. Don't forget to like, share and subscribe. Any doubt, go through the video once again, simply explained. Thank you for watching.